Hello guys, I'm Yurii Babich and welcome back to our course on Python programming. Today we're going to be talking about looping statements. You create a loop when you need your program to do the same operations iteration by iteration. So let's start from the while statement. Here is the idea of how it works. First of all, it checks the condition. Here you see the corresponding syntax, while statement, and then you put the condition. If the condition is fair, then Python interpreter goes to instructions that are given in the block after the while statement. Pay your attention that this gap should be 4 spaces, because in Python there are no special brackets, there are no begin and end statements, so only that indentation tells the Python interpreter that it's a block of instructions. So while the condition is true, the loop is created here, so these instructions are executed. When the condition returns false, then interpreter goes to the else block and performs corresponding instructions. So pay your attention that else is the feature of Python in this case. I mean, when you use while, so you can add the else statements, and that is a feature of Python. If the condition is false from the beginning, then only the else section is performed. Now let's take a look how it is done in real life, and pay your attention that this loop can be endless, because if the condition is true all the time, then you're getting the loop here. Now let's get back to our program from the previous lesson. So the game on guessing the number. So here you see that we have 2 variables, the number our user should guess. Cycle is the variable we need to break our cycle at some point, because otherwise it's going to be endless. And then we have the while statement itself. So while cycle, and the cycle equals true, then the next block of code should be executed. So first we are assigning the value to the guess variable, and we're getting that value through known function. So we use the input function, and what the function returns is converted to the integer format through the int function. Now we compare our guess to the number, and if they are equal, then we type brilliant. By the way, let's do a small correction. Then we assign the new value to the cycle variable. We say it's false to stop the cycle. If the guess is wrong, we compare the guess and number, and depending on the result, we type no, it's higher, or no, it's lower. By the way, pay your attention at this syntax, so you know this from the previous lesson. So this backslash helps us to output this comma. Now let's start our program. So let's enter the right guess. So we see brilliant. Then we see the output of the else block. So when the while cycle stops, the else block is executed, and then we see the code outside our loop. Now let's try again. Let's start it again. So let's put something like this. And we see that our loop continues because we haven't assigned the new value to the cycle variable. So, or we can place something like that. So our cycle won't stop until it gets the right answer from the user. So let's do that. The question is, how can we stop the execution of a loop if we want so? There are two keywords helping us with this task. These are continue and break. Let's start from break. The idea of break is to stop the cycle completely and exit the loop even without executing the else instructions. So here is the idea. So we start our loop, we check the condition is true, then we go to checking the condition for break. And if it is true, then we go outside the loop. If it's false, then the block of instructions will be executed. Now let's get back to our example and let's take a look how it works. Now let's say I'm gonna put the break. Oh, my bad. I'm gonna put the break statement here. So let's save our code and let's start the program. From this point of view, we expect to loop to be broken after we enter the value of the guess variable. So let's try it out. Alright, so let's enter any value, and you see that the loop is broken and we see the code outside our loop. So break expression actually stopped our cycle and proceeded to the code outside the while loop without any comparing between variables. So when we put break, so it breaks cycle here. Now let's take a look at another keyword that we can use to influence a cycle, and that keyword is continue. So here you see how it works. So we start a loop and then we go to check the continue condition. If the condition is true, we are not exiting the loop, we are going to the new iteration. So the cycle starts from new iteration. So the cycle continues. And that is a difference between continue and break. Break actually breaks the cycle, while continue passes to the new iteration of the cycle. Now let's take a look at how it works. Let's get back to our example. So Let's put our continue the same place we had the break statement. And let's start the program. So let's enter something, and we see that our loop goes to the new iteration, but the loop is not broken, so we are still in the loop. Here is the difference in the case of continue. So now let's continue. So another looping statement in Python is for in statement. So first of all, this statement works according to this logic. So first, we provide something iterable to the for statement. Iterable means we can take more and more values from this object. So here is the syntax for variable in, and then we provide something iterable. It can be a list, it can be a tuple, it can be anything iterable. Then we put colon, and then we put the block of instructions. Of course, in the case of a for cycle, we also can use else block with corresponding instructions. First of all, you should know that this cycle cannot be endless, so it won't run forever on this loop. Why? Because this something iterable will end at some point. So how it works? We actually interpreter check if the sequence is over, if there are some values that can be taken from the iterable object, then it goes to the instructions block and performs the instructions. When the iterable object is over, it cannot provide any more values, then our for statement actually is expected to go to the else block with corresponding instructions. Now, the keyword of break and continue, you know, from the while cycle are absolutely applicable to the for cycle, so you can freely use it here. Now, let's take a look at our example. So we have it here. And what you should pay attention at is this. Pay attention at this sequence. We have 101, 2, 15, 8, 19. So it's the feature of Python. The iterable object can be almost anything. So the numbers shouldn't be in ascending or descending order. So you can use the sequence like this without any order, or you can put a string there, so it's gonna work. Now let's do this cycle. As you can see from this syntax, actually it prints what we have provided as an iterable object. So let's start this program. So we see its output, so we see these numbers. Pay your attention that after doing the main block of instructions, interpreter goes to the else block and performs the else instructions, and after performing the else instructions, it actually exits the cycle and goes to the rest of the code. So this is the code outside the for loop. Now, but what if you need like 1,000 or 10,000 of iterations, so you won't be writing that like 1, 2, 1,000. How to generate iterable object containing the necessary sequence you want to provide to into the for statement. So in this case, you use this syntax. So you write in and then range, and then in brackets you specify starting value, the last value, and step. By the way, pay your attention that it will be stop -1. So let's try it out. In range, one, comma. So if I want to have the range between 1 and 10, I should do this. I can omit the step because by default the step equals 1. So let's save this code and let's write it. So yes, you see that we have generated the sequence from 1 to 10, and we have provided that sequence to our for statement. We have printed these values with the print function. Then we see the execution of else statement, and that's it. So of course we can use like break statement. Let's try it out. Yeah. So it breaks after the first iteration and exits from the loop. So these are the loop statements in Python, so you can use them freely. They're really handy, and they're very flexible in their implementation. Now let's go to functions in Python. So by this point we have used inbuilt functions like print, like input, like int or bool or float, but in Python we can define our own functions. To do that, we're going to use the following syntax. So the keyword to define the function is def. Then we provide the name of a function. By the way, guys, pay attention to use the informative names. So don't use the name like F or A or B. So use the large informative names for your functions and for your variables, because the code you write should be easy to read and easy to support. Now, after the function name, we provide arguments of the function in brackets. Then, the first string after the name of the function is so-called docstring. You use that string to write some description of your function. So here you describe what your function does. And to do that is a good idea, because someone who will read your code should be absolutely clear about what it does and so what the function does. So use docstring. And I hope you remember from the previous lesson that the help function actually reads the docstring. We're going to get to that in our example a little bit later. After docstring, you provide instructions to the function, and then you use the return keyword and you specify what the function should return. Because by default it returns nothing, and we're gonna take a look how it works. Now let's start from writing our function. So here is the code. We use the def keyword and then we define the function that is called absum. And here in brackets we specify two arguments that should be provided into this function. Take a look at this syntax. Here you specify what type of arguments, what type of data should be provided into this function. Because, as you can see from this syntax, the function returns sum. And we can sum integer to integer, integer to float, float to float, or we can sum two strings. But we cannot sum, let's say, a float and a string. So, someone who will be using that function should understand what kind of arguments should be provided to that function. So it's really good idea to use this syntax to provide the information about the type of arguments that should be provided to the function. And of course, take a look at this. This is our docstring, so this is some sort of help on our function. So now let's run this function and let's see how it works. Alright, so let's start absum and let's provide two values to it. Let's say 3 and 7, and we see the sum. Alright, so now let's check our docstring. Let's check the help on our function. So to do that, we are using the help function and we provide, the name of our function to it. Yep, and as you can see, we see our docstring. In other words, we see the explanation on what our function does, what kind of arguments should be provided to it. So this is the idea of how you define the function. Now, by the way, let's provide our own arguments to our function. So let's do it like this. So let's provide 2 or 5 and let's say hello. And as you can see, we see the error message because there is no way to sum 5 and hello. Either two strings or float and float and integer, but not integer and string. Now, let's get to this. Here we see the function that actually does nothing. The pass keyword means that interpreter should go to the next block of code. So, but the question is, what does it return? So, what kind of data returns function that does nothing? Alright, so let's define such a function and let's research it. So let's define function f that does nothing. Let's just colon and let's type pass. Now let's assign the value, the return of the f function to the a variable. And now let's check what is the type of the a variable. So type a. Now we see that it is function. So let's do it another way. Let's do it like this. And now let's try it again. So, and here we see an interesting type that is called none. None is a type of Python, so means nothing. So the function returns nothing. So guys, looks like we're running out of time, so we're gonna start from this moment our next lesson. So please write your comments and questions in comment section below the video. That's it for today. See ya.